On a cold January day in 1952, engineers approved a bridge design that relied on a thin layer of stone to protect its foundations from the river's relentless pull. They chose shallow concrete footings spread wide beneath each pier, then covered them with a dry blanket of riprap, loose rocks meant to deflect the current and keep the soil underneath from washing away. The assumption was simple: as long as the stones stayed in place, the creek could never reach the concrete. That decision, made more than 3 decades before tragedy struck, would become the bridge's undoing. The Schoharie Creek Bridge rose over the water near Fort Hunter in 1954, a 5-span ribbon of steel and concrete carrying the New York State Thruway. Its piers sat on those spread footings, each one a squat block of reinforced concrete just deep enough to meet the standard of the day. For years the riprap held, and the bridge carried traffic without incident. Then, in the spring of 1955, hairline cracks appeared in the concrete plinths, signs that the stones were shifting, that the water was beginning to nibble at the edges. A flood that October confirmed the threat, and by 1957 crews added extra steel to the plinths, hoping to stiffen them against the growing strain. But the real danger lay unseen beneath the riprap. Scour is the process where fast-moving water sweeps away sand and gravel from around a foundation, leaving the concrete unsupported. The engineers had counted on the stone armor to stop that process, but they had not accounted for how a violent flood could lift and carry away even heavy rocks, or how the creek's flow could concentrate and intensify around a pier already weakened by debris. On April 5, 1987, a sudden surge of meltwater and rain, 150 millimeters in a few hours, turned the Schoharie Creek into a raging torrent. The flood approached a 50-year event, its power far beyond anything the riprap had ever faced. First, the stone shield around Pier 3 gave way. Water scoured the soil from under its footing, the concrete tilted, and the pier collapsed. The falling concrete and twisted steel slammed into the river, creating a jam that redirected the current and increased its speed toward Pier 2. 90 minutes later, Pier 2 succumbed to the same scour, its footing exposed and washed away. 2 hours after that, Pier 1 followed, its span shifting as the foundations disappeared beneath it. In the chaos, a car and a tractor semi-trailer were already on the bridge when it gave way. Before responders could seal the gap, 3 more vehicles drove into the opening. Over the next 3 weeks, 9 victims were pulled from the creek. The 10th was found months later in the Mohawk River. The collapse forced a reckoning. Engineers realized that relying on a superficial layer of stone was insufficient for bridges exposed to major floods. New York State overhauled its bridge design standards, requiring deeper foundations, often piles driven down to stable bedrock, and mandatory scour analyses for every water crossing. Inspection protocols grew stricter, with underwater probes now routine to detect hidden erosion before it becomes catastrophic. The Schoharie Creek tragedy turned a flawed assumption into a catalyst for safer, more resilient bridges across the nation.